Okay, hello, my name is KangyoonLee, and today I will present on the topic of a study of synthetic data with generative AI models with using sensitive transportation driver data. Let's begin the presentation. Our agenda is as follows. Let's start with the introduction. I'll discuss with focusing on research background. Before delving into our research background, let's briefly understand what privacy infringement is. First, I'll pose a quiz for you. Guess who is the person currently in this hall with this information? The answer is me, because I'm attending hoops right now and suitable for all this information. Through this quiz, we can discuss the concepts of personal information and privacy infringement. First, personal information refers to single and complex information that can identify an individual. Second, the concept of privacy infringement refers to the act of someone with using data combinations to identify someone, like quiz I posed before. With this background, let me explain the project we conducted. Our project was to use driver data from the Korea Transportation Safety Authority to identify ineligible drivers, predict related accidents, and provide feedback. However, there was a privacy infringement related to our data. Let's illustrate a simple example in our data. We had a data set 10,000 transportation workers. We filtered the data based on 3 columns: location, industry, and license type. We give a specific value for each column as follows. You can see that in the first example, 10,000 people were identified as 2 people, and in the second example, it's 4 people. These 2 examples indicate a situation where someone could be identified. This highlights the risk of privacy infringement in our data. Given these considerations, we concluded that we couldn't use this data. After careful consideration of how to use data, we realized that instead of using the original data, we should use fake data. So we focused on how to generate fake data and which approach would yield the most accurate fake data. In essence, this led us to a shift in the project direction from development-centric to research-centric. The fake data's answer was synthetic data. It is a kind of data which excludes personal information while following the distribution of the original data. In short, we can call it as privacy-preserving fake data. If you use synthetic data, there are a lot of benefits. First, data privacy protection can be ensured. Second, it can be augmented and expanded freely. Third, this flexible data can fill in missing classes so that data imbalance can be addressed. Based on this, the objectives of our study were to generate synthetic data from the raw data from KOTSA, then compare, analyze, and evaluate which technique produces the most valuable synthetic data. Now, I'm going to explain the research process more in detail. The basic flow is as follows. Route the data, processing, use methodologies, make synthetic data, and finally calculate the accuracy. First, let's talk about the data. We received a total of 10,000 data points, 18 columns from KOTSA. The columns in this data as shown below. The upper row is the names of the columns, and the bottom 5 rows are the values of each column. The red boxed columns are the ones that can be used as a basis for inferring a specific individual. About basic statistics of the columns, I'll show you simply because of time limitation. We've shown integer data, the average, maximum, minimum, and units. Same way, in the categorical data, the count and ratio of those values are shown. Now I'll explain the data preprocessing. First, we split complex column to derived columns. Second, categorical columns was converted to integers with using label encoding. Given the preprocessed data, How can we generate synthetic data? Our exploration led us three main methods: Bayesian, machine learning, and differential privacy. Each of these methods has various sub-methodologies. We reference other papers and consider which approach would be most suitable for our data. We first explore the Bayesian method, which is statistical approach to generate synthetic data. Based on this paper, this method focuses on the relationships between columns. However, in our data, we didn't need to focus on relationships between columns because there were many essential columns such as industry and license type, where determining one can determine the other. So the various relationships between columns was subtle. Consequently, we didn't prioritize the Bayesian method as our initial consideration. Next was the differential privacy method. This approach focuses on ensuring the protection of personal information. However, since the sole purpose of the generative data in this method is protection, so its utility can be compromised. Our data need to be useful for our next project before I show, so our data utility was important. So we didn't prioritize this method neither. So we adopted a machine learning methodology. In the recent era of big data, the field of machine learning has been developed rapidly as the amount of data has increased. So we wanted to apply these methods to our data. We chose GAN, CTGAN, and VAE, which are the most commonly used machine learning methods for synthetic data. I wanted to explain each model's learning architecture, but I'll skip because of time limit. Now let's talk about performance evaluation for each model. First, we plotted the distribution of synthetic data for each model. Out of 22 columns, we selected location, industry, and license type columns, which can be used to identify individuals. From left to right, the model is represented, and top to bottom, column is represented. The charcoal color behind means the distribution of the original data, and the cyan color is synthetic data's distribution. Looking at GAN and CTGAN first, we can see that they follow the distribution well for each column. However, CTGAN follows the raw data distribution more closely than GAN. VAE also follows the distribution fairly well for the three columns. Additionally, we analyzed the distribution for the columns with biased columns, driving experience, and current status, which has a wide or narrow spectrum code. Like saying, CTGAN follows the distribution as well. To be more specific, we used two indicators to select the optimized model. This paper expressed the reproduced quality of structured data, which used column shape and column pair trends column as evaluation indicators. Based on this, we also tabulated the accuracy of all models. We can see the GAN, CTGAN, and VAE models from top to bottom. Let's look at the first indicator, column shapes. Column shapes means the similarity of how well model reproduce the distribution for just one column in our data. Based on paper below, 80% above said to be meaningful. So our purpose was to filter model with more than 80%. As you can see, GAN and CTGAN has a meaningful rate, and CTGAN get highest result at 87%. The second column, column pair trends, shows the similarity and correlation between the two columns. For example, in the columns of industry and license type, if the raw data has a correlation of bus and type 1 license, does the synthetic data follow the same correlation? It means if synthetic data has a correlation of bus and type 2 license, it means synthetic data's correlation mean low. Same way, 95% above is said to be meaningful, so GAN and CTGAN performs well. Finally, there's the overall quality score. This is the average of the previous two indicators. As you can see, CTGAN had the highest recall at 91%. We cross-validated these results. We made synthetic data for 1,000, 3,000, and 5,000 data sites respectively. For each amount of data, GAN had reproduced in the high 80% first row, and CTGAN in the second row is low 90%, and VAE in the low 80%. So we can estimate that CTGAN has the highest recall for all scales. Now let's talk about the conclusions of our research. I'll skip this recap of our research because time limitation. And let's summarize the expected outcomes of our research. First, it can contribute to K-digital platform project implemented by current government. Second, it can stimulate research in the field of open data which contain personal information. Finally, it is expected that it can be ground for convergence analysis of public and private data in public institutions. Future work in our research includes these things. First, we need validation on datasets with different sizes, properties, and values. We also need cross-validation with other methodologies such as Bayesian and differential privacy. We also need use cases to see how our approach works in real-world industries. So this is the references that we use in our project. And thank you for listening.
Okay, thank you for your presentation. What is your contribution for this paper? Or just creating the synthetic data?
Yes, right. And if we make synthetic data and give to, can be used in K platform that current government is projecting, maybe K digital means a lot of spectrum that we can use IoT and other smart systems. So if we keep and sell the protected data, they can develop their own career.
Okay. Another question, the technical side, you just used there is a very famous the model, the gang model variation. Do you have another model try your model?
So as you can see in this second column, there are a lot of generative AI models that can be used. So we are developing another models we use in autoencoders, and we get this information from that paper, first one. So in this paper, it indicates a lot of generative AI models that can make synthetic data. So we are referring that paper.
Okay, so do you have use a customized model? Do you try yourself customize?
Customized?
Yeah, it's your proposed model.
Oh, we don't have, and we just get.
Yes. Yes, you just using all just in the famous model.
Yes, but we changed the like hyperparameters, and we set the best fit to run our models. Only that change.
Okay.
Okay. Is there any reason you choose the driver information?
Pardon, please?
Do you have any reason to choose driver information data set? What is the purpose of this one?
This synthetic data.
No, the driver information.
Driving information. Because
Why do you choose?
because our original project was.
Yes, you have original project.
Yes, so this one, and the KOTSA wants to predict the adverse illegible drivers if they give us the transportation workers data, and
So you want to find some illegal driver information?
yes, right, illegible drivers, like who makes a lot of accidents and who drives.
Okay, I guess. After that, do you have any plan to extend your paper?
At first, we want to try a Bayesian method because Bayesian method depends on the relationships between columns.
The Bayesian method
And another AI, at first, another AI model, we want to.
How much do you times?
Maybe it will take 1 week. I guess 1 week.
Okay.
And Bayesian method.
Then I want to answer.
1 week.
Thank you.
Thank you.
Thank you very much. Very nice presentations. Now we have another presentation from Hangul University of Foreign Studies.